So, do you mean like my favorite metal band, or just
I guess
favorite
your
band in
favorite
general?
cyberpunk metalhead band.
Yeah, very good question. I've been listening to Behemoth a lot lately.
Ah,
Um,
throwback.
they're a really good like black metal band, and
Mhm.
they have a tour coming up with another very friendly name band called Rotting Christ next year in April.
Well, don't know that
But
one.
they're really good.
Awesome. I used to listen to like kind of a lot of Clutch and who's Danzig, people like that. Some of those bands.
Yeah, yeah,
Some good
yeah.
old
They
school.
like the old classics, right?
Yeah, yeah, definitely. Well, I was born in the '80s, so grew up in the
Right.
'90s, and in a good era for that kind of music, I think, as well.
Like Pantera as well. I think they were back in
Yeah,
the 80s, right?
Caius. Caius was a big favorite for a while. Yep, lots of
Yeah,
different
It was
Venom, I think.
peak peak culture.
peak culture. Are you
Big
scared?
culture.
Did you? I can't see you being a metalhead. Did you get into any of that?
I love everything, but I'm more of a jazz guy. Not to date
Yeah,
myself, but
see that.
No, that's cool. I mean, I love jazz myself. There's this really cool like dark ambiental jazz that I like to play some like late at night. It's called Bohren, Bohren. It's like really like dark and ambiental. It is really nice.
I'm gonna need a link to that, sir. Genuinely though, I really have moods where I enjoy almost any kind of music, and in terms of like research, my main area is like sequence processing. And music is a
Right.
sequence too, so I actually really enjoy some of the math of math of music is really interesting.
Oh yeah, there's a lot of it in there, right? And I think that's also probably one of the things that kind of attracted me to something like the metal genre is that it's so incredibly precise, right? You're working with like 180 plus BPM. You have to make sure that if you're hitting both pedals, you got to make sure that it kind of lines up with the voice and with the drums and like with the guitar track as well. It's very precise, right? But also, I like
You
the
know,
like the
sounds almost like running a Web3 protocol. I'm just kidding.
I mean, Web3 protocols, they're not always known for how precise they are. Because if you're talking about oracles, we've got like gaps in there that we still need to fill in, and we kind of need to come up with new solutions for this. There've been actually some great innovations in oracles lately, like Chronicle. They've been doing some amazing work
I'm
into
very
oracles and making that more like robust. Yeah,
yeah.
So what you're kind of saying is that Ali would be the Pantera of Web3.
I'll take
that's a
it.
pretty cool way of putting it. Yeah, 100%. Just coining the genre, just redefining the genre. Why not?
Well, I'm
Yeah.
a big fan of.
First it was Satoshi, right? Black Sabbath.
Have you heard of the band Apocalyptica that does those like concert band
I
covers
did.
for
Is it
bands?
the one with the cello, like the cello band?
Yes, yes, because they were classically trained and they do all metal covers. They're amazing. So
Yeah,
yeah,
they're really good.
maybe that's what we're doing in crypto, changing the track up. Hey.
I think that's a really good way of looking at it. Just kind of changing the tempo, but just remixing the old.
Yeah.
But
So
genuinely excited to have you both here. I think there's you guys are doing some amazing things. And before we get into Lilypad itself, I kind of want to get a bit of an understanding from both of you, like where do you come from and how do you actually got into crypto? Like, what's your journey been like, and how did you even come across crypto in the first place?
yeah, absolutely. And how do we meet each other is another good story, I think, as well. Around internet. So my name's Ali. I'm Australian. I live in Melbourne currently, but I live in Sydney, and I've lived all over Australia really. I had a bit of a winding journey to get into tech itself to begin with, and then into crypto. So I actually owned a cafe for most of my 20s. I ran and
Oh
owned a
wow.
cafe on the coast here for most of my 20s. And then I sold that and I went back to uni, a university or college, depending on where you come from. And I studied mechatronics engineering and computer science at university. And while I was there, I think, part of it was I'd already run a business. I kind of had that entrepreneurial um, vibe, so to speak. So when I was at university, I took advantage of a lot of the groups and helped organize hackathons. I came across all sorts of cool people in the space doing really amazing things, and it just really, the tech space was just something that. Really made a lot of sense to me, and that was trying to, do something to solve problems in the world. So I went into the software engineering side of it, and even ran a startup while I was at university. Actually, I was writing my thesis for mechatronics engineering, and a business partner and I were going through an accelerator doing a startup, and I was doing 3 full-time subjects. I don't know how I did it, but it was kind of a crazy time. But like lots of learnings from that. We decided not to continue with that business because we would have. My business partner didn't want to take funding, and I didn't really want to bootstrap for 4 years straight out of college. So I went on
Yeah.
to corporate life. I actually took a job at Accenture, and we were building out. We were part of kind of a specialized team that was building out an AI ops actual product for Accenture, and then implementing it into like the Fortune 500s, which is a lot of banks and mining companies in Australia generally. So, a lot of both hands on the tools work as well as understanding the kind of user's perspective and what they needed out of the tooling that we were providing. And then I moved into a job doing R&D work, more software engineering, but leading up software engineering for a development at the University of Sydney here that was working with our Air Force on some sensors. So working with the physics department on some really cutting edge sensor material there, including they had a dry room, sorry, and everything that we used to like look at. So it was really great working with some amazing academics there that were working on kind of some cutting edge products. And then got poached by IBM actually. So I went and worked at IBM, and that's kind of where I went down the blockchain rabbit hole as well. This was after Hyperledger had come out, so about 2020. But still looking back on IBM's journey with Hyperledger was super interesting. And also, kind of did a lot of kind of pre-sales work at IBM. So I was working across their range of products across, they just bought Red Hat, across AI, and seeing their AI history as well and implementing that for clients. But one of the interesting things for me was IBM had just bought Red Hat, and one of their big narratives was around how you should have no vendor lock-in. You should be able to take your data anywhere. You should be able to move your compute loads. And Red Hat's an amazing product and team, don't get me wrong. But it felt like in this context, it was like, well, why aren't we designing that from the beginning? Because at the same time, I
Right.
was looking at this ecosystem, this public open blockchain ecosystem, and particularly people like Filecoin and Protocol Labs, and seeing this same narrative but building from the ground up. So I actually went and took a job at Filecoin Protocol Labs then for 2 years, and that's where Lilypad actually began. So yeah, that was a long story, but yeah, I started working on a few different products at Protocol Labs. So very deep down the blockchain rabbit hole by this stage, obviously. And we were working on decentralized storage and then decentralized compute on a project called Bakuya, which was a peer-to-peer protocol for compute execution. Headed by David Aronchik, who was one of the original founders on Kubernetes, or
Mm.
original developers on Kubernetes, one of the leads there. And that's actually where I met Stan. Stan was playing around in the Bakuya ecosystem, and we had a few chats about what was going on in the compute space. And yeah, I'll let Stan tell his story now as well. But we kind of vibed. It wasn't until a while later when we launched Lilypad, which is kind of an incentivization layer on top of, well, Bakuya originally it was. It's kind of developed into a bit more than that. That I asked Stan to come aboard and lead up our research division here, and haven't regretted it. So it's been amazing.
I'll continue to do my best not to piss you off, Ali. And I have to say, so excited to hear the full Ali story. I'm kind of taking notes. I hadn't heard kind of your whole arc. And you're gonna have to send me a copy of that thesis. I want to read that.
Oh no,
Same.
no, yeah, we'll do.
Um, And yeah, I'm a Stanley Bishop in the Web3 world. I sometimes go by Science Stanley. That's my kind of decentralized science guy character. Um, but I
Love it.
am a sort of scientific technologist in real life too. I design software that runs on high performance computing clusters, and specifically in the area of bioinformatics. I'm really passionate about the application of machine learning to biology. And yeah, most of my career over the past 10 years has been helping, companies that design medicines build big computers. Like I'm just like, let's hook up as many computers as we can. That's my kind of energy when it comes to this stuff. Um, have I would say like felt in my heart a deep pain working in this area, seeing how decisions are made, and have seen so many systems that really had the potential to change, lives, just get thrown out because it didn't have the 10,000x profit motive. And at the same time, when researchers can't get access to compute, we have literally 20 to 40% of the world's compute sitting there doing nothing. So when Ali let me know that she was working on a solution to this like kind of tragic misalignment of resources, I was like, let's do it, let's do it. And then that's I think one of the things I'm really passionate about is connecting, the compute on the Lilypad network to researchers out there who need it.
I think that's a fantastic story from both sides. I actually took some notes because I have two questions, one question for each. So I'm going to start with Ali because you mentioned you started off, you used to run a coffee shop. My
Yeah.
first question is: A, did you sell that coffee shop? B, do you still own it? And C, does that coffee shop accept cryptocurrency currently?
I sold it actually before I went off to run to university. But I make the joke that I did everything the wrong way around, right? You're supposed to have the startup first and then you retire to the coffee shop. I
Yeah.
just
Pretty much, yeah.
I'm like all wrong. No, I think it was a great learning experience though to have when you're younger. Although I would also recommend traveling the world, folks. Uh, but a great experience to have when you're younger and gain some leadership skills. I think on the ground leadership skills. I think there's no other way to learn how to lead other than to do it and to think about it.
100%. I think it's one of the best ways to learn. Like you acquire so much more like actual practical knowledge when you do stuff rather than when you read about stuff or just get passively exposed to it. I think there's a balance. Maybe 80% do, 20% read. You're probably going to be in a much better place than just you know be theoretical all the time.
100%.
And my follow-up question is, like you said, you studied software engineering. What exactly was kind of like your expertise in software engineering? What was the thing that attracted you the most about software
Yeah.
engineering?
Sure, sure. So I studied mechatronics engineering and software engineering. In Australia, it's kind of, you can do a double degree, it's called. So I started out in actually mechatronics engineering, or just engineering actually, and moved into mechatronics, which is robotics. And as part of that, we did a software course because you need to know how to program your robots. And that was actually my first foray, really, other than when
Right.
young typing out dir/w on our old IBM computer. But other than that, that was kind of my first real foray into software engineering. So I was quite late to software engineering, well, comparatively, like people grow up knowing it these days. Um, but yeah, quite late to software engineering, and I just like really loved that you could do something that would affect how things ran, and you could codify that, and then it would show up on your
Right.
screen, or you would, be able to code up an algorithm that did the same thing each time, or would sort things for you. Like that was kind of just black magic to me at the time. I was like, this is amazing. I feel like I'm in control of the world. That was one of my initial feelings. And being really annoyed at my professor who like took marks off for semicolon or something like that. I remember. Anyway, but just like that kind of you can codify the world feeling. I think I got when I first wrote some Hello World code and then wrote some sorting algorithms. I think we did something like that. And then I learned more and more about it, and got into the startup and hackathon scene a fair bit. I helped organize some of those, was part of some of those societies in my local town. Um, we actually ran one of the biggest hackathons in New South Wales, one of Australia's biggest states.
Oh wow.
Yeah, that year with the IT society. So that was, really cool, and met a lot of really great contacts that I still have. Actually, one of the people that also works with me is a contact that I met at that hackathon. So some really seminal moments, I think, and just seeing how much, well, firstly, how much innovation was happening, how much people had ideas and wanted to try and change things and wanted to try and solve things. Like, that was amazing. And the other one for me, as kind of a woman, was like seeing how much flexibility a career in software engineering gave me at the time as well. So I was quite attracted to the fact that, there were jobs that had flexible hours that you could work from anywhere. And here I am running a completely distributed crypto company from my lounge room. So in Australia. So that was definitely something that attracted me as well. Just the conditions, especially for someone like a woman or someone with kids. I thought that was brilliant at the time as well.
Absolutely. Yeah. And I think I completely agree with the sentiment that it feels like magic because first time you do some back end stuff. And I'm guessing because of robotics, it had to have been back end. It had to have been low level like C++ or something like that.
Yes,
It
my
is,
first
it is,
language.
yeah.
Everything's been easy since.
Exactly. Like if you start off with C++, there's not like you go down to assembly and then there's nowhere lower that you can go down the stack. Like that's it.
Exactly. We did assembly too, electrical engineering. uh,
Really? Wow.
we did some assembly. Just, I think, to give an idea of how much the code affects the hardware, or the hardware affects the code as well. So, yeah, well, it was a great background, it turns out, for running a distributed compute company.
Yeah, yeah, absolutely. And I like how like you both of you kind of synergize on this and I can see the passion coming, from both of you regarding software engineering because Stanley, you've mentioned and I meant to ask you about this like bioinformatics. I really want to know more about that because I haven't heard that term being thrown around too often and it sounds like there's a potential gold mine in there in terms of like what do you actually do or did.
Oh, absolutely. And quite frankly, I think this is a topic you're going to be hearing a lot about in coming years. There's a number of technologies that are lining up to really change what's possible with bioinformatics in terms of impact on our health, but also in terms of some other areas. And actually love the kind of topic at the intersection of hardware and software because it was actually in that context I met Ali at Protocol Labs and learned about Bacalao. Actually, doing a project that was looking to help the world's oceans with genetic testing. It turns out that since the ocean is such a deeply interwoven food web, if you take just a glass of ocean water and you sequence the DNA of every single species that has DNA floating around in that glass of water, which can be thousands and thousands of different species, you actually get a fingerprint of what's going on in the ecosystem. And we think that that data is going to be a key part of, let's just say, not dying due to climate change.
Wow. That's
Um,
mind-blowing.
Yeah, but there is one thing that we say in this project where we're attempting to kind of like operationalize the world's ocean data, and that is there's nothing more decentralized than the ocean, right? It's all over the place, and so it really is a use case where having technology that can run verifiable software containers on demand anywhere is kind of critical.
Yeah. That's super cool. And was bioinformatics what you used to do before Lilypad, or does bioinformatics still kind of play a role in your life, I guess?
Yeah, bioinformatics is most of what I do. I work on projects usually that are trying to design medicines or understand rare genetic illness. But just like Ali, I'm a big open science person, love to contribute in different areas.
Yeah.
Interestingly, though, I started off in language processing for Google like 10 years ago. And like I was saying, though, a sequence is a sequence is a sequence to an AI, whether it's a linguistic, musical, or genomic.
Got it. That's fantastic. I think that's some really unique set of skills. So I'm guessing a big part, or at least a substantial part of something like bioinformatics is machine learning, right? Like you're looking at a set of data, and then you're trying to understand how this interacts under various conditions. Like, if you change one variable within that subset of like that cup in the ocean, then what are the implications? Or like plotting the future of humanity or ocean health based on changing variables or something like that. Don't know if I'm
Yeah,
making
no, that's
sense. I'm just
totally correct. No, it's totally correct. And I just have to say, I actually particularly love talking about this subject with computer scientists such as yourselves, because really bioinformatics is just an informatics subject. You might call computer science computer informatics. It's about data in one form transforming to another form, and a dance being carried out in that process. And yeah, 100%. In bioinformatics, there's actually multiple different types of data, and they all interact with each other. And so it's a very hard problem for humans to understand unaided, and this is actually the year when we've had the key breakthroughs. Like literally in the past 3 to 6 months, we have what are called scientific foundation models that you can say speak genomes. And yeah, we're absolutely using those to understand what's going on in the ocean, and what's going on in a patient's body. And on some level, those are not two different things, just a bunch of molecules floating around in a soup.
absolutely. It's just data points. It's just you have a whole bunch of data points. If you can somehow make sense of them with an algorithm, with a machine learning process or something, then you can glean some insights within that ecosystem, whether it's a human body, the ocean, a tree, a fungi farm or whatever.
Yeah,
Yeah.
absolutely. I think one of my favorite stories, actually, that I've learned from Stan is around. So he introduced me to a character called Michael Levin. I don't know. Have you ever heard of him at all, Andre? A guy,
No.
Michael Levin, that works on is an AI scientist that works in the biological field, and he's working on some fascinating. He has an interview with Lex Friedman that you should listen to if you're interested. But he
I will
works
definitely be checking that out.
yeah, he's using both kind of his understanding of software engineering and his understanding of biology, because I believe he did both, to model out, or not model out even, to kind of fundamentally propose. Yeah, I mean, you should talk about that as well, OpenFold as well, Stanley, but to fundamentally propose that maybe we're going about some of the training of human biomes. I think this is right, Stan. You can interrupt me if I get this wrong, but it was to instead of giving them instructions like a recipe list, what we really need to do is just empower them to be an arm or be a leg and let them do it. And I think we're coming around to doing the same things in a lot of AI as well, or we have different understandings of AI depending on what you want to apply it to. But I think that's one of the ways we can do it. And I think another really interesting thing, and that was specific to this Michael Levin character, who's like a leader in this field and just super fascinating. Seriously recommend it. But another thing that Stan's introduced me to is OpenFold, which is this protein folding, and this requires masses and masses of data and masses of compute. But this will fundamentally be able to map out what goes wrong where, and us be able to really change the human trajectory. Like, this is what's so exciting, being able to enable compute for applications like that, downstream applications like that. That's where the real breakthroughs are happening. That's where we, solve cancer. That's where we, have fundamentally new ways of, making sure we're healthy. I don't know. It just is going to really change. AI is going to change everything, but that's one of the things, like that and climate change. Those are some big subjects that I think AI can really, really have an impact on, and hopefully, like, by giving access to compute to people, to SMEs, to subject matter experts, around the world that don't necessarily have that on-demand compute. We can like kind of help enable that. That's one of the exciting things for me about building this project. Anyway, sorry, went on a bit of a rant, but
Oh,
I just
Ali, we love your rants. Can I just take a second to shout out though? Ali is wearing the coolest T-shirt in the universe. I'm still
oh
waiting
yeah,
on my Lilypad Pac-Man T-shirt. Lilypad gobbling up all the world's GPUs. I hope you won't mind though if maybe before jumping into talking about OpenFold, because I think this is really important. I would love to say just a word or two about Dr. Levin, who runs a big lab at Tufts University. And yeah, his appearance on the Lex Friedman podcast is a must watch. If I can get you to watch that, my job for the day will be done. But I think at the beginning of the podcast, he talks about something pretty incredible. There's a organism called a planarian, and it's a weird little invertebrate marine creature. And if you cut it in half, both halves regrow into a full creature, and
Wow,
both halves have the memories of the original creature.
that's
so
insane.
which is the which is the original.
Somehow.
uh,
And how does the data get there? Where is the data stored in the body
Exactly.
that when you cut it in half, the data that was in the brain is able to repopulate in a completely new brain that grows? And this is what I think Ali was homing in on. Dr. Levin has some theories about a certain type of intercellular informatics that could be almost a hidden firmware layer of our bodies. And this is what Ali was referring to, that like there might be a signal, you could give your arm to tell it to be a leg. Now, that doesn't sound very desirable, but if you can kind of extrapolate what would be possible. And Ali, I love too. It's so fun, kind of sharing ideas and hearing them back. And you got it 100% perfect, except for one small thing.
okay.
And this is just something I'm sharing because it's important. Dr. Levin, actually not an AI scientist. He's a biologist and a synthetic biologist, but he's an interesting person because he is a world leading expert who needs access to these new AI and machine learning tools and doesn't have it. And so he was introduced to some of my collaborators in the open source world, and we're going to be working with him to create some new molecules. And I think it just goes to show that there is an enormous opportunity in making this hardware available. And then just shifting to OpenFold real quick, have you heard of folding at home?
No.
Well,
Not
this
the
this is where I'm going to have to apologize for ranting, but Folding at Home is the OG collaborative computing project. It was launched from the Panday Labs at Stanford University, which is where I learned a lot of my chemical machine learning. And it is a program that you can download on your computer, and then you contribute your excess CPU cycles to folding proteins. Um, there was a technology discovered maybe 3 or 4 years ago called AlphaFold that really changed protein folding forever. It used to be something that needed thousands of CPUs, and now you can do it on one single GPU.
Oh,
So
wow.
folding is one of the verticals that we're really excited about mobilizing the Lilypad network for. But yeah, back in the day, the only way that a researcher trying to make a medicine could kind of create the protein to understand if it could be a good medicine was to submit it to this folding at home network. And anyway, I'm kind of homing in on just one of my favorite anecdotes. I actually got started in bioinformatics as a middle schooler. Me and my friends lived in Palo Alto, and every day after school we would go take our rollerblades up Sand Hill Road, and we dumpster dive for any computers that the VCs threw out. And then we had this big wall. I'm thinking of that as Lilypad 0.00000001 alley at this point. But yeah, we would just hook up every computer we could, and we were just trying to get as many folding points as possible.
I love it. It's
That's so cool. That's such a cool story. Also, it's fascinating. I did not know about folding at home, and it's fascinating to see that there's a network that's dedicated to that. It feeds into, right, and correct me if I'm wrong, but it feeds into, like you were saying, Ali, potentially curing cancer, but also figuring out why it is that at some point our cells or our regrowing and reproducing of cells kind of breaks down, which is why you age, which is eventually why you die. So technically, you
yeah.
could keep running this machine learning algorithm forever and ever until it finds out exactly where does that breakdown actually happen within the DNA, within the actual like cells,
I
and
mean,
how to
absolutely.
mitigate that.
Hopefully, in the next 10 years, so I can reverse it. That would be great.
Yeah. So then do you guys think that if we're thinking in terms of right blue sky thinking, let's say immortality, can we achieve immortality? Is it more likely to achieve it biologically or through a perfect body that just doesn't age or through a or consciously like uploading our consciousness or extracting our consciousness and just having it live, in a machine that doesn't age by design?
Big question. Are you if you're in a machine? I mean, I think there's already a lot of companies providing kind of AI afterlives. Like there's enough information on, well, on some current day people at least around to provide pretty realistic AI models of what they would do and say in certain scenarios. And I'm fairly sure there's, well, I've heard them. I can't think of any names off the top of my head, but there's companies already creating pretty lifelike AI versions of that person. I guess you would need to, maybe evaluate some of the arguments from the singularity is near to decide if that is a person or if it is not. Uh, have you heard of that book? Uh,
Is it Kurzweiler? Robert Kurzweiler?
Oh, I mean, have I heard of it? I read it 100 times when I was 10 years
Yeah.
old.
I only fairly recently read it, so yeah, it's fresh in mind as well.
It,
But yeah, you might
incredibly prescient though, right? Like I feel like he's just calling everything we're walking through right now, you know?
absolutely. Well, I mean, this is an updated version as well, so he has
Right.
put in a few of the things that we're seeing recently, but he also specifically refers to this is what I said, here it is, so to speak. But yeah, amazing.
I
Sorry,
think
we've
I've heard. No, no, it's all good. I think so. I haven't read this recent iteration that you're mentioning, but I heard him speak about it on a Joe Rogan podcast a few months
oh,
ago, and he was saying that at the time, like we currently get, because of medical advances, we get about 4 months in a year back, 4 out of 12. So we
wow,
only age about the equivalent of 8 months a year because of all the medical advances. And he proposes in that book that we'll actually get to the point where we'll get all of our 12 months within the next 15 years or something like that. And beyond that
Yeah,
point, you'll
what do
get
they
more
call
than
it?
12 months.
Longevity escape velocity. That's the
Yeah,
phrase,
right. Yeah,
I think. And
exactly.
it's an interesting one, and definitely like the synthetic consciousness is something I'm a little less qualified to comment on, although actually doing some pretty cool work on brain data. Um,
Hmm.
I do have to say though, and forgive me for sharing something a little personal, but a little earlier this year, maybe my closest friend passed away. He was
Sorry to
one
hear
of
that.
one of my main collaborators in rare genetic illness, and it has been such a loss. There's just so many moments where I miss him, but then so many moments where I'm working on something and I want to talk to him. And I actually did, I sort of specialize in post training. So I took every conversation we've had over the past 10 years, it added up to like thousands of pages. And I trained a model and I've been talking to it every day and it's been helping me with problems. And I have to say, it does feel like talking to him, and I don't know how to really understand it much more than that at this point, but it's, man, a whole can of worms that we're opening.
it's
Um,
amazing.
on the longevity front
Yeah.
too, the biological longevity front, um, with things like curing cancer or curing aging, I'm like very careful with saying too much or expressing too much, but like, man, the pieces are coming together. The pieces are really coming together. And aging isn't something that has to happen. Cancer isn't something that has to happen. Whales, for example, don't get cancer. There's zero cancer in whales, and it just happens to be that there's something in their genome that's set a little differently. So I really do think these problems are solvable, and it's a matter of getting the data and getting the tools. Really excited actually right now to be working on a pilot with a group called the Human Pangenome Consortium, and they're international consortium of genetics departments that kind of establish the best practices and standards around genetic technology. And they're right now working on something pretty interesting that you might actually enjoy reading about if longevity is interesting to you. It's called the T to T genome, or the telomere to telomere genome.
Mm,
The telomere is like the end cap of the genome, or you might
right.
also think of it as like the header of the genome. It kind of expresses how the sort of genome should be read, and it's believed to be one of the main parts of our genetic data that accumulates defects leading to aging. And so, first step is really seeing how the telomere changes as we age, and other epigenetically determined parts of the genome, and then yeah, seeing how do we repair that damage, how do we prevent that damage. I think it will be possible, but right now the telomere to telomere, exactly, Ali. That's what it is. And that's what's so funny too, is because when we, had the Human Genome Project, we thought that was it, that that we had the source code of biology. But yeah, it actually turns out there's many layers of data, and they all kind of interact with each other. Anyway, big punchline: sequencing one patient T to T right now costs $500,000, and there's
Wow.
only been 50 patients sequenced. Really, fortunately, actually, three of the patients I work with have been sequenced, and it was actually this is kind of cool, Ali. It was the University of Western Australia that
What?
donated the sequencing, and
That's
it
amazing.
turns out that they actually have a really big mission in making sure Indigenous people are represented in our genetic data. And then they view rare disease patients as like brothers and
Right.
sisters in that struggle for representation. So anyway, we just got to get that 500,000 down to $50 though, and I think we'll be ready to roll.
So when you say sequencing, you mean that their DNA data was mapped out into this machine learning system?
Yeah. Yeah, their DNA was sequenced. Out of a sequencer, you get all these little fragments, and then you put the fragments together. You think about it as like putting together a puzzle. Um,
Right.
Most genomes are like 98% accurate, like if you go to your doctor and get a genome. But it turns out that 2% that you miss is actually where some of the most interesting stuff happens. So.
Oh wow, I did not know that. I did get a 23andMe test recently, and it was quite interesting. But I recently just read about 23andMe and how their stock price just kept plummeting for the last few ever since they gone public. Um, and I'm not sure if there's any kind of big scandal there. I wouldn't be surprised if there were, though.
I mean, I think we saw their entire board resign last week, and so yeah, there's
Oh
going to be
fuck,
some
yes.
majorly bad stories coming out of that one.
Oh no, you're absolutely right. I forgot about that. Yes. Oh jeez.
And worth mentioning too that the only other company with a similar data set, which is called Decode Genetics, was bought for like $8 billion by Amgen. So I would say 23andMe an all-time epic f up.
Yeah.
Wow.
Yeah, honestly, to have access to that much information and just it's a shame really, if anything.
Mm.
But
Showing
hey,
the
doesn't it make you wish we had good cryptographic protocols for data sharing?
and the
I
ability
feel
to
I feel like there's a punch in there somewhere. There's you're trying to say something.
Ugh, Ali, this guy's too smart for me.
no, he is. I think, I mean, it's a point though, right? It is a really big point. One of the reasons that I refuse to do that eyeball thing and haven't like gone and got DNA testing is because where's my data go? I'm not sure if I'm getting asked permission for my data to be included. Actually, it's really interesting because
Mm.
My family is actually fragile X carriers, which means we can have slower
Oh.
children. It seems to be stable in our line, and it's actually
Right.
really interesting because we've had enough of our family tested that now they use our line for comparison to other people because our line is so stable. It appears like the gene doesn't mutate; it just continues stably, which is really interesting. So yeah, I think in terms of data, we need more of it, but also I think it needs to be permissioned at the same by the same token, right? I agreed to do that.
Mm.
They asked me for permission to use it, and I said yes. But I think there's definitely a lot of companies out there that are really just making money off your data rather than doing the right thing by it, like we want them to be.
100%, yeah. So having gone through the 23andMe process, the questions that I was asked was, are you happy to have your anonymized data be used for cancer research? I go like, yeah, sure, go ahead. Are you happy for us to store your genome data and details in case someone with a similar DNA is looking for, like, people from their like family? And I was like, you know what? No.
I didn't know enough about it, but that's great.
Yeah, exactly. But yeah, obviously that just brings us to, how do you take all that power and all that, all that learning, and use a system that's provably fair, right?
Mm.
Which is obviously a lot of what you guys have been working on. So maybe I think having a high level overview over how Lilypad solves some of these issues, I think that would be super interesting.
Yeah, absolutely. So I think at its core, we're not going to say solve all of those issues all in one protocol, but what we can enable is on-demand compute for the SMEs in the field that know what they want to build. And that know, where the problems are. Really, we definitely don't want kind of centralized versions of all of our AI models because that just leads to biases being inherently spread until we're basically just one big culture. We need diversity to thrive, and I think this is something that an on-demand distributed compute network can help provide by providing that kind of democratic access to the resources you need to build these kind of models to solve these kind of problems that we've been speaking about for the last 20 minutes now, I think, or are really hashing out. So at its core, we're a distributed compute protocol, but we're really hoping
Hmm.
to build out from there, add storage, add those protocols, building out great data layers, great privacy layers, and become part of a decentralized AI system in the world as well.
Right. So I think it's really interesting. You mentioned distributed, not decentralized. Is that distinction on purpose? The decentralized could be, anyone can own this token, but one person may own up to 90%. Distributed means everyone on the network owns the same amount.
Yeah, I think it's an interesting distinction. So, how I distinguish it is from a tech view rather than from an ownership view necessarily, because we're decentralized, so the nodes don't belong to us. We're just building out the protocol. We take a fee per job because we need to continue to build this system. But otherwise, like the nodes don't belong to us, the models don't belong to us, the data doesn't belong to us. So in quite a lot of ways, we're completely decentralized and actually building. We're just helping to build trust in a distributed
Right.
network. So actually, to kind of use them a bit interchangeably,
Yeah.
there is a
Cool.
distinction, though. You're correct.
Awesome.
Yeah, in terms of the token, we will be releasing a token. We're not releasing that until early next year, alongside our main net. It will be.
So what network is it on? I'm sure you mentioned it at the beginning. There's something starting with B, but I think I've forgotten the name of it.
No, so we're actually compute doesn't happen on chain. It happens off
Right.
chain, obviously, but just in case anyone was wondering. And then we provide these on chain guarantees. Now we're completely EVM compatible, so we'll be launching a multi chain. We want to be where users are, right? We want them to be able to access it in whichever application they decide to. That includes across the different Web3 chains, and that then also includes the Web2 world. So providing those APIs, those SDKs, and a SaaS layer even for folks in the Web 2 or traditional tech world to be able to access this without needing to know about tokens, without needing to know about cryptography, without needing to know how anything under the hood works, and just needing to know that they can have an on-demand, GPU available to run their jobs on the network. Sorry, I think I like completely went away from your question there.
No, no, I think it's cool. I think I have like a lot of questions around the way like your the nodes, the way they work, the way you choose kind of um
Sure. So
how do
currently,
you decide like what kind of job to give a certain node? Is it based on their specs? Do you run different models or different algorithms based on the kind of like parts that a node has, or do you have specifications in terms of what kind of compute CPU, GPU, a node should have to be accepted onto the network?
yeah, absolutely. So currently we're in an incentivized testnet phase. So like most marketplaces, you need to bootstrap both sides of the network until you get to an inflection point. This is true of pretty much any marketplace. So at the moment, we're incentivizing or providing rewards for GPUs to join our network before there is a lot of demand or a lot of paying demand on the network. At the moment, we're only encouraging NVIDIA GPUs because of the way that we're providing proofs. But we certainly have a plan to make sure that we are GPU neutral, and even CPUs, like Stan shared before, the folding project that is just using spare CPU power. We can certainly provide jobs that are CPU or that run on an AMD or that run on Intel as well in future. So currently, if a job comes into the network, what happens is it's offered up as a job, like it's broadcast to the network. Hey, a user here wants to run this protein folding job, let's say. And then the network goes, oh, like it sends a broadcast out and multiple GPUs go, oh, I can do that job. I am a 4090, so I meet the requirements for this job. And also like have a great reputation, so there'll be a reputation system, and also I'm close to where you are, or have low latency, so for those regions,
Right.
for example. At the moment, the matching is just by the requirements of the job, so needing say a 4090 to run, or needing whatever it is to run. In future though, there'll be more sophisticated matching that occurs. Then the job is launched, and the GPU providers can name their price, so it's a marketplace. Um, and then the job is run. And then the big problem in a decentralized network like this is, how do you know that this node, this GPU that you don't know anything about and could be anywhere in the world, has run the job that you wanted it to run? Now, it's easy in a deterministic, well, easier in a deterministic network because you can rerun the job, you can check it. But in non-determinism, it's a little bit more difficult. So we're using kind of a blended verification method, and it'll be a multi-verification method as well. It will definitely depend on what type of job. If we're looking at AI inference, we're kind of using a blended method that checks how much GPU was run and does kind of some sampling of the job along the way, alongside a reputation for this node to verify that that job was run.
Right.
And the client, so the person that proposed the job in the first place, can go, I don't think you did the right job. And then a mediator, so a separate node to the um, hardware provider, the GPU that ran the job, can step in and do some verification on whether the job ran or not. Um, that also will happen in a random sampling of different times. So yeah, sorry, that was the long discussion, but one of the big problems in these kind of networks is providing trust. So that's what starts being complicated in some of these decentralized marketplace situations.
Of course, yeah, and thank you for the explanation. I think that was actually really, it was really fascinating to hear you speak about it. The only one question that I have is, you've mentioned the a job gets matched with a node.
Mhm.
Is it a plan to always be like one to one, or do you guys have plans to fragment the job into clusters so that you could have a pool of nodes running the same job and then just giving you the result
Yeah.
back?
really good question. So currently it's one to one, so embarrassingly parallel jobs, but actually due to the executor, which I spoke about earlier, Bacalhau. So we use Bacalhau as our compute executor under the hood still.
Hmm.
It is cluster enabled. That means, for
Right.
example, if you onboarded a data center, that job could get sent to this node that says it has 100 A100s. And you could run a machine learning job for many days in this data center on demand, just about. Provided you have the right resources on the network, then that's absolutely a possibility to spin up clusters.
This is a use case we're particularly excited about because in the enterprise space, there is an enormous demand for large language models that are conscious of a company's data and records. And there's in a lot of areas either an inability or a large hesitancy to send all that data to OpenAI. So lots of people need fine-tuned custom open source models like the Llama 405 billion model that are trained on uh, proprietary data, but remain in total control of the entity, and so it's actually one of these offerings that we think is going to be extremely high impact. Allowing companies to have access to these models without giving away all of their data.
Yeah, absolutely.
100%. There's just I feel like there's way too much reliance right now on OpenAI and ChatGPT. And like don't even get me started on how it was founded as an open source AI for everyone kind of solution, and then it's a closed source for profit, even hinting at spending 2000 charging $2,000 a month on the enterprise O1 plan. um, I
Well, I
think it's
mean,
a weird
I put in my
turn.
deck actually open AI, so I have made the joke before. No, I totally agree. So we shouldn't start down that hole, though. We'll be here for another hour.
Yeah, 100%. So when it comes to pricing, then how competitive is Lilypad against something like using AWS's recent AI farms?
Yeah, absolutely. So I think where our competitiveness comes in is because we're a peer-to-peer marketplace. There really isn't a middleman. So that means you can, other than the small fee we take, there's no reason to think this wouldn't be up to 20 times cheaper than going through something like
Oh
AWS,
wow.
which has a lot of layers of different things they need to support. So the build out of the protocol, the like data centers, the people running the data centers, the people like working on their next product or stealing it from open source. Did I say that out loud? Or the list kind of goes on. So there's no reason to think that. I don't have a benchmark on pricing, but it will definitely be cheaper than running on AWS.
Nice. That's great to hear. Stanley, I think you want to talk about FHE, and I'm really looking forward to hear you talk about it because I've recently got acquainted with FHE, and I think it's fantastic technology, but it's not without issues.
Oh my gosh, I'm so excited to talk about this. But can you guys hear me? Okay, I'm actually having some lag on the line.
You're
All
all
good,
good.
my end.
Okay, well, stop me if it's at all laggy. I'm having a little trouble hearing you guys. Um,
Yeah, I can just jump in there for a second while Stan refreshes a little bit as well. So we've actually been talking to, and we have an advisor who was working
hey,
with
hello.
Zama, which is the French homomorphic encryption company,
I
and
know
that's all.
Zama. I spoke to them.
Yeah, yeah, I listened to that podcast actually. That was really well, really good.
Thank you.
We're very excited for fully homomorphic encryption and very open to adding it as a privacy measure in our protocol. At the moment, my understanding is it's quite difficult to fully encrypt a full model, but you could you could FHE your data at the moment and send that in and out. So full privacy is probably too slow at the moment, but they're getting there, and I'm very excited to see. And follow along with where that goes, and we're ready to put that in as soon as it's ready to go, basically. So our protocol is quite modular in that respect. And I'll let, now that Stan's back, I was just talking about
Yeah,
Xamarin, Stan.
um,
Uh,
so sorry too, guys. I don't know why the video's lagging out, but hopefully you can hear me. And I want to say about FHE, I believe we will look back on this moment as part of the pre-FHE era. That when FHE reaches the level that Ali is alluding to, where we can actually conduct all of our data and machine learning operations through encryption, it's going to change the world. Like it's going to be something where, it isn't just there's some cool tricks that we can do on Lilypad. It's like every mainframe in the whole country will be FHE'd by default.
well, we
I can talk a little bit more about why I think that, but then also I feel like maybe you should talk about like what FHE is or what it allows us to do. And I remember that box you checked on the 23andMe, right? Like, is it okay for my data to be used in cancer research? And I do a lot of data science for oncology. Like, I've been active at Stanford Medicine for a number of years working on patient cases. And I get yelled at by oncologists a lot of times, like, we need to find certain data or we're trying to get certain data from a biobank and we get the data and there's something wrong, like they mislabeled it or it's sort of like the data is contaminated. And it's a really challenging process, like getting the data, navigating health and privacy issues, as Ali alludes to. And so I would like genuinely say that for every day of useful work, contributing to the development of a particular precision therapeutic for a cancer patient, we waste 7 days chasing or cleaning data, and it's just a pain. And foundation models have this potential to totally change that. If I train a foundation model on, say, every breast cancer case that has been sequenced, I can generate data from that model. I can generate synthetic data that can be used in the design of a therapeutic without ever seeing the data of the underlying patient. So we have
Right.
potentially a way of making, all of the benefits of data availability happen with none of the downsides. But you do have to pool all that data for the training, right? And that is an incredibly difficult cat herding exercise. But with FHE, these groups could put their data together pooled for training with trust and, train the model through FHE, uh, delete the underlying data after, and then you have the model that can be, used by clinicians. And, again, that's just one example of what I think FHE is going to allow.
Yeah. Well, I think it will also it'll get people to be more comfortable with sharing sensitive information. But when I say sharing, allowing sensitive information to have computation run on it, and that will in turn just create a richer understanding of anything really. Like you're no longer feeling uncomfortable having someone perform computation on that piece of data because it is never unencrypted at any point, right? That's the magic of it. Though I do understand that one limitation, and I'm not sure if this is bearing any weight on Lilypad at the moment on your guys' solution, is that it's a lot slower than plain text computation by a
That's
thousand
fine.
times or up to 1,000 times slower than plain text. I know that people at Zama have been making great progress in getting around that. It is still significantly slower, though I do expect, and I think everyone expects that it could get a lot faster as they have new breakthroughs in that technology.
Mm, absolutely. And I think one of our theses as well, or one of the things, one of the trends you can see happening in AI as well is that, models are getting more and more optimized for particular tasks. And so they're getting smaller while still being more powerful. So I think, there's a possible meet in the middle there for some essential models, not necessarily, your foundational model for oncology there, Stan, but for many popular models. They're getting optimized at the same time as FHE is getting faster. So I'm sure there'll be kind of an inflection point there where they kind of meet and it makes a lot of sense as well. But not everything needs to be private either, I would suggest. So, definitely looking forward to having FHE be rolled out. And I think even when it's slow, I think that's still valuable. Like if it takes, say, 3 months to train with FHE instead of, a few days or something, Is that better than not having the data at all? I would say yes. so so maybe it's still a breakthrough, even if it's slow, and maybe that doesn't matter. Depends on the use
Yeah.
case.
No, 100%. I'm really looking forward to just seeing more of that across the web
Absolutely.
and compute. I think
Yeah,
it's going to be
absolutely.
magical.
I think our fundamental thesis at Lilypad is to make sure that we have a underlying marketplace in play, ready to go on demand when you want to use it. And then these are layers that we add on top. So FHE will be almost like a plugin for Lilypad that you can choose to use, or that's privacy. You might also want more verification on the compute that you're using. So you might put in ZK into your job, or things like that. So these are definitely modular value layers that can plug into the Lilypad compute network.
That's super cool. So, one big question, when is Lilypad going to be deployed in the mainnet?
Yes, so we're looking at a release date in probably late Q1, early Q2 next year. So we're currently in incentivized testnet phase, though. So if you want to run a GPU, that's currently already being incentivized, and we're aiming to release our next phase of incentivized testnet, which is folks building models and modules on Lilypad for other folks to use. That'll be coming in the next month, and then there'll be lots of other community activities, so you can help educate, or you can, help contribute to the network in many other ways as well, if it's something that's of interest to you. We'd love to hear from people that provide storage or data, or people that think that they could use a network like this as a part of an overall decentralized AI strategy too. We're always looking to hear from cool projects that would want to use compute or would want to plug into creating an decentralized AI ecosystem.
So, it's not exclusively for decentralized AI, though, is it? You could also run any sort of computation. Could you use it to run a web application or a sorting algorithm or anything like that?
Absolutely. That will definitely be possible, and already is possible, actually. So, yes, you can already do that. One of our fun little hello worlds is actually, Calsay, the little, you give it a prompt, and it comes up with a cow saying that prompt in ASCII art. It's actually our hello.
Ah,
It's actually
um,
Lily Hello World, and that runs on a CPU. So, yes, absolutely. You can run other jobs on the network.
Ali, I hope you won't mind if I jump in to plug one of my favorite LilyPad sub networks under development, and that would be in a non-machine learning vertical, in the quantum computing vertical.
Oh, of course. Yeah.
It turns out we have way more quantum computing researchers out there than we do quantum computers for them to work with. But many steps of the quantum algorithm design process can actually be simulated on GPU. So we're actually hoping that one of the big application directions of Lilypad will be where a quantum researcher goes to test their algorithm first time.
That is so cool. Yeah, I think quantum computing is not as explored as it should be at the current time. Um, Also, one cool thing about FHE is that it's quantum proof, by the way. So there's no way to once quantum computing is going to be everywhere. FHE will remain encrypted and will remain safe, which is a nice added bonus for that.
Just have to make sure we sell our Bitcoin, right? No, just.
Yeah, exactly. Just jump ship as soon as you can. Uh,
Oh man, I'm kidding. I'm sure there'll
I
be
was
enough.
actually thinking about that. It's surprising that it hasn't happened yet. Like there are quantum computers out there on the market. Is it maybe just a matter of like they're way too slow to break like the encryption algorithm?
Yeah, well, I think it's that a demand issue. There are certainly a number of quantum computers, but there are many researchers, and I believe that for non-government researchers, there's often queues of 2 to 4 months to get time on a quantum system. And yeah, like many people I work with in this space whose opinions I trust describe this as a national security issue, that we really need to be making sure that researchers aren't blocked, and that they're able to kind of move forward. And yeah, I think it's just such a cool, high impact opportunity for Lilypad.
Do you guys have? Are you working with anyone that's running quantum computers at all, or is there anyone on your network that's running them?
Yeah, absolutely. In fact, I think this is maybe a little too early to fully let the cat out of the bag, but we have a pretty interesting partnership coming together with some very large hardware companies and an incubator called Q-Force that actually is a really beautiful community of quantum researchers who are kind of like working together to, support each other's products and research. And, we're hoping to maybe place some quantum compute simulation grants in that ecosystem of researchers.
Wow, that's super cool. I love the idea of quantum computing as much as it eludes me. Like I think about qubits and superposition, and I'm like, how is that possible? And the only way to understand it as a programmer, as a software engineer, is to get your hand onto one of those quantum computers and just to write something and see how it compiles, which
Right.
I'm yet to do so.
And you are right, except it's also possible to do some of that on GPUs. And you can use a framework that NVIDIA makes called Q Quantum, CU Quantum, which stands for CUDA Quantum. And yeah, it's amazing. Like you can actually start to develop some intuition about these elements and how they interact informatically. Although we must always remember the words of Richard Feynman, the true quantum field theory master, who said, if you think you understand quantum, you don't understand quantum because
Right.
his illusion is that it isn't understandable with our silly little monkey brains.
I mean, yeah.
Yeah. Yeah, Jamie, pull up some DMT. They'll
It's so funny though. Actually, it's my original training was in quantum informatics, and it was actually like I came to bioinformatics when I developed a rare disease. I became very passionate about disease and care and stuff. But hey, that's the fun part is it's all just like bits flipping, right? It's just information dancing.
Yeah, exactly. It's also super fascinating, and I have so many things to research after this podcast. It's probably the most I've learned out of any episode I've done, and I absolutely love this.
I love it. Love it. That's amazing.
I have to say too, you'll have to have us back on. And I think this is like really reflective of the Lilypad culture. And I hope you won't mind if I take a second to plug the Lilypad community and encourage anyone who likes this kind of stuff to come check out the Discord. I really think that, we've built a community that's driven by curiosity and exploration and mutual support, really in a way that mirrors the intention of the network.
And thank you so much, guys, for coming on. I think, like I said, I think you guys are doing some amazing work. I would love to have you both back in the future. You've said you're planning the launch in around Q1, Q2 next year. I think it would be super interesting to hear from you guys how the launch went and what your plans are once you're up on the mainnet. So you're always welcome to come back here, and I would love to talk more bioinformatics, decentralized computing with you guys. It's been an absolute pleasure.
Absolutely. We'd love to come back. And thank you for hosting us, Andre. That's an amazing conversation.
Oh, in closing, do you have any socials that you wanted to shout? So I
You
don't
can
forget.
find Lilypad across Twitter, YouTube, LinkedIn under Lilypad_tech. Most of our socials are on, and our Discord is also at discord.lilypad.tech. We should give you a quick link to our Discord invite if you'd like. We mostly hang out in there, including Stan. So we're pretty public about what we're doing as much as possible, and we're pretty active in the Discord. So you'll find us there if you want to talk to us one to one.
Amazing. Thank you so much, guys. And Stan, have a lovely rest of your day. I hope caffeine kicked in. And Ali, have a good night. I guess.
Thank you, Andre. I'm going to go get some sleep. Great
Yeah.
job. Thanks,
Lovely
everyone.
talking to you both. Nice meeting you.
You too.
Oh, this was really a treat, man. Thank you so much for having us. And Ali, always like really love when we get to chat about this stuff.
Me
It's the
too.
best.
Me too.
Fantastic energy, guys. Thank you
You too.
again.
Bye.